Following on from the previous video, we've established that if you use this as a model and then you combine the area with the height, you will get a 3D solid. Well, this 3D solid, as it turns out, it has some sort of usefulness associated with it. It serves us, it allows us to calculate things. So the point is that the 3D solid here has some sort of usefulness associated with it. Well, if you use the same model, if you get a graph plot and plot this, you would get a graph looking like this. Well, the 2D area, as it turns out, it has some sort of usefulness associated with it as well. So if you look at the height of a population, you're going to get a lot of average people here. Okay, so this here is your average. You're going to get a lot of people clustered around the average. But once in a while you get a tall person, once in a while you get a short person. Suppose you want to know the height, suppose you want to know the probability of a certain group of people within a certain height. So within a certain range of height. So you would need to consider the area of this thing here. The point is that if you use this as a model, the area has some sort of usefulness associated with it. It allows us to work things out. And in the previous video, we got to a stage where the volume of this, if you use this as a model, the 3D volume, that's you revolving it 360 along the y-axis, the 3D volume is a lot easier to calculate than the 2D area. That's the stage that we got to in the previous video. So the volume is really us summing up all the shells from 0 all the way to infinity, from 0 all the way to infinity. And let's just look at, so we are moving in the x direction. Let's just look at this one particular shell. We would need to consider the circumference of a circle. So this is the circumference. And then we would need to combine that with the height. Well, this here is the height. So the volume is given by this. The point here is that let's just take the 2 pi out because it's a constant. So that would then leave us with this. The point I'm trying to make here is that it's easy to work out the integral of this. It's a lot easier to work out the integral of this than it is to work out the integral of e to the power of minus x squared. You see, this here is very difficult to calculate. This here is a lot easier. We will actually need to get to multivariable calculus in order to truly work this out. But for the time being, let me just illustrate why it's easy to work this out and this not so easy. Okay, so let's look at this. You see, for us to integrate this, we would need to search for something. We would need to search for something in such a way that when we differentiate it, it would give us this thing here. So we would look at this thing here and make an initial guess. So our initial guess would be e to the power of minus x squared. This would be our initial guess. So let's just imagine this as being in a bubble here. So this is our initial guess. Let's differentiate it. That will then give us e to the power of minus x squared, and then we need to times with the derivative of the bubble itself. So that would be negative 2x, negative 2x. So that's the same as negative 2x e to the power blah 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 here. So the point here is that when you differentiate this, it will give you this. So for you to evaluate this, you would need to make the adjustment. So the adjustment would be negative a half. Okay, so the point here is that you see we would start out with an initial guess, and when we differentiate it, we would get this convenient x here. You see, you've got this nice and convenient x here. If you try and integrate this, if you try and use the same technique for this thing here, it wouldn't work because when you differentiate this, you're going to get, you see, this here does not have an x hanging around. It doesn't have a convenient x hanging around, whereas this one here has a convenient x. So let me give you another example. If you see, this here is easy to integrate because notice that you've got this thing here, convenient x to the power of 6. Well, this is easy to integrate because we would start out with you see, this here is easy to integrate. This here is not. Hang on, e to the power of this here. This is not easy to integrate. This is easy to integrate. So let's try and integrate this. So we would start out with our initial guess. Differentiate. So we are looking for something that when we differentiate it, it will give us this thing here. We are looking for this. We are looking for something that when we differentiate it, it will give us this thing here. We'll make this to be our initial guess. Differentiate this, it will give us. Well, imagine this as being in a bubble here. Differentiate it, it will give us this. And then we've got to times with the derivative of the bubble itself. So that will be negative 7x to the power blah blah. And then that's the same as negative 7 x to the power of 6 e to the blah blah. Notice that x to the power of 6 here is nice. It's easy because you've got this nice convenient x to the power of 6. So if you try and use the same technique for this, okay? So we are trying to find out the area of this thing here. If we use the same technique here, let's use the same technique. Let's try and integrate this. Okay, so we would need to search for something in such a way that when we differentiate it, it will give us this thing here. So let's let's use our normal technique. Make an initial guess. Let's imagine this as a bubble. Differentiate it, it will give you this thing here, which when you tidy up, it will give you this thing here. You see, you've got an x here, but our target is us looking for something in such a way that when we differentiate it, it will give us this thing here without the x. But when we did it, we've got this x here. We don't want this x, so we could try this. Okay, let's make this to be our initial guess. So let's try and make this to be our initial guess. When you try and differentiate this, it would here, because you've started out with an x. Hang on, let me go back one step. So we are trying to evaluate this. Okay, if you try and make this to be your initial guess, when you differentiate it, it will give you this. You don't want this x. So let's try a different guess. Let's try this guess here, where this is our initial guess. Well, if you make this to be your initial guess, then you've got to use a product rule here. So it doesn't really work. So if you try and differentiate this, so this being your initial guess, if you differentiate this, you've got to use a product rule because you've got one thing multiplying another thing. So keep this the same and differentiate this, and then later on leave this the same and differentiate this. The point is that when you differentiate this, it will give you something that's really complicated. So integrating this thing is not easy. Okay, it's not easy. So integrating this here is not easy. Finding out the area of this is not easy. It will require a lot of work, and we are going to work through it. Okay, so our next aim is to work out the area of this thing here from negative infinity all the way to positive infinity. But by the way, you can just work out from 0 to infinity and then later times 2. Okay, well, I will guide you through it in the next few videos.